Welcome, and thank you for joining us for today's webinar. My name is Catherine, and I will be serving as your moderator. The presentation today is entitled, The Critical Role of a Streaming-First Data Architecture in 2017. Our presenter today is Steve Wilkes, co-founder and CTO of Striim. Steve has served in several technology leadership roles prior to founding Striim, including heading up the Advanced Technology Group at Golden Gate Software and leading Oracle's Cloud Data Integration Strategy. Throughout the event, please feel free to submit your questions in the Q&A panel located on the right-hand side of your screen. With that, it is my pleasure to introduce Steve Wilkes.
Thank you, Catherine, and welcome everyone. So today, I'm going to talk about what is a streaming-first architecture and why is it important to your data modernization efforts. We'll talk about the Striim platform, and we'll give you some examples of what customers are doing and the solutions they're building using our platform. We'll take some time to give you a demonstration of how it all works, and then open things up at the end for questions and answers. So, most of you are probably aware of this, the world moves fast. And it's not just the world, it's the data that moves fast. Data is being generated largely by machines now. And so businesses need to run at machine speed. You need to be able to understand what's happening right now and react to it immediately in order that it's not too late. At the same time, customers and employees' expectations are rapidly rising. And part of the reason for this is the smartphone boom and people's access to real-time information, the ability to see what's happening to your friends, what's happening in the world, instant access to news, instant access to messages and communication. And because the consumer world is instant, those consumers are also employees and executives and expect instant responses and insight into what's happening within the enterprise. And the quality of applications you used to deal with is also driving desire for similar quality business applications. The other side of the coin is that businesses need to compete, and technology has always been a source of that competition. And as technology is rapidly changing and we're getting more and more data, businesses that are more and more data-driven have a competitive edge. And businesses now have almost all departments ranging from engineering or manufacturing all the way through to marketing being incredibly data-driven. And so the survival of most businesses depends on their ability to innovate and utilize new technologies. And data itself is also massively increasing. Almost everything can generate data. It could be trucks, your refrigerator, TVs and wearable devices that you have, healthcare devices that are becoming more and more portable. Even things like salmon making its way from being caught to a restaurant is tracked and produces large amounts of data. And this data is growing exponentially. IDC did this study a couple of months ago, and they're estimating that today the 16 zettabytes of data. By 2025, it's going to increase tenfold. And of that data, around 5% of it now is real-time, increasing to 25% of it in 2025. And by real-time, they mean it's produced and needs to be processed and analyzed in real time. So that's 40 zettabytes, 21 zeros, of data that will need to be processed in real time. And of that, 95% of it will be generated by devices. The kicker really is that only a small percentage of this data can ever be stored. There are physically not enough hard drives being produced to store all this data. So if you can't store it, what can you do with it? Well, the only logical conclusion is that you need to process and analyze this data in memory in a streaming fashion close to where the data is generated. Maybe you're turning the raw data, 1,000 data points a second, into aggregated data that is less frequent but still contains the same information content. So that kind of thing is what people talk about as edge processing, but it's really trying to handle these huge volumes of data that people see coming down the line. And it's not just IoT data that arrives in streams. everything, or every piece of data is generated because something happened, some kind of event. Someone was working on the enterprise application, someone was doing stuff on a website, or using a web application. Machines were generating logs based on what they were doing, the applications generating logs, databases are generating logs, network devices, everything generating logs, but they're all based on what's happening, based on events. So if the data is created based on events in a streaming fashion, then it needs to be processed and analyzed in a streaming fashion. If you're collecting things in batches, then there's no way you'll ever get to a real-time architecture and a real-time insights into what's happening. But if you collect things as streams, then you can do these other things. You can do batch processing on the streaming data. You can deliver it somewhere else. But at least the data collection needs to be streaming. So stream processing has emerged as a major infrastructure requirement and is helping drive enterprise modernization. So moving to a streaming first data architecture really means that you're transitioning at least your data collection to real-time collection. You're not doing batch collection of data, you're doing real-time collection of data, whether it's from devices, files, databases, wherever it's originating. And you're doing this incrementally. You're not trying to boil the ocean and replace everything in one go. You're doing it use case by use case as part of your data modernization projects. And this means that things that have high priority to become real-time, to give you real-time insights and potential business competitive edge, or better support for your customers, or reduce the amount of money you're spending on manufacturing and by improving product quality, any of these things can be drivers to data modernization, and you're doing it use case by use case, replacing pieces of it, bridging the old and new worlds of data. Now, some of the things that our customers are telling us are, we have these legacy systems, and by legacy they can mean anything that was installed, over a year ago, and they can't keep up, or they don't predict that they'll be able to keep up with the large amounts of volumes of data that they're expecting to see, with the requirements for low latency, real-time insights into data, and with the ability to rapidly innovate and rapidly produce new types of analysis, new types of processing that will give you new types of insights into what's happening in your business. They're also telling us that we can't just rip and replace these systems, and that you need to have the new systems and the old systems work together with potentially failover from one to the other while you're doing this replacement. So Striim has been around for around 5 years now. We are the providers of a platform, the Striim platform, that does streaming, integration, and analytics. The platform is mature. It's been in production with customers for more than 3 years now. And those customers are in a range of industries from financial services, telco, healthcare, retail. We're seeing a lot of activity in IoT. The Striim is a complete end-to-end platform that does streaming, integration, and analytics across the enterprise, cloud, and IoT. We have an architecture that's very flexible that allows you to deploy data flows to bridge enterprise, cloud, and IoT. You can deploy pieces of an application at the edge, close to where the data is generated, and that doesn't have to just be IoT data. It can be any data that's generated. But close to that data, other pieces that are running on-premise, doing some processing and analytics. Other pieces are in the cloud, also doing processing and analytics. It's very flexible how you can actually deploy applications using our platform. Those applications consist of continuous real-time data collection, and that can be from things that you may think of as kind of real-time, sensors that are sending events, message queues, etc., and then things like files that you may think of as batch processing. We can read at the end of the file, and as new records are written to the file, stream that out immediately, turning files that roll over, etc., into a source of streaming data. Similarly with databases, most people think of databases as a historical record, what's happened in the past. But by using a technology called change data capture, you can see the inserts, updates, deletes, everything that's happening in that database in real time. So you can collect that non-intrusively from the database and stream that out. So now you have a stream of all the change that's happening in the database. So all of the applications built with our platform use some form of continuous data collection. On top of that, you can then do real-time stream processing. And this is through SQL-based queries. There's no programming involved, no Java, no C#, no JavaScript. You can build everything using SQL. And this allows you to do filtering, transformation, aggregation of the data by utilizing data windows. So you can say what's happened in the last minute. You can look for change in data and only send that out, etc. And then enrichment of data, which is also very important, and that is the ability to load large amounts of reference data into memory across a distributed cluster and join that in real time with streaming data to add additional context to it. So an example would be, if you have device data coming in, and it's device XYZ, value 123, that doesn't mean much to things downstream that might be trying to analyze it. But if you join that with some context and you say, well, device XYZ is this sensor on this particular motor on this particular machine, now you have more context, and if you include that data, you can do much better analytics. On top of the stream processing, you can actually do streaming analytics. That can be correlating data together, joining data from multiple different data streams and looking for things that match in some way. So maybe using web logs and network logs, and you're trying to join by IP address. And you're looking for things that have happened on either side in the last 30 seconds, that kind of correlation. We do complex event processing, which is looking for sequences of events over time that match some kind of pattern. So if this happens, followed by this, then it's important. You can do statistical analysis and anomaly detection and integrate with third-party machine learning. We can also generate alerts and trigger external systems and build these really rich streaming dashboards that allow you to visualize the results of your analytics. And any of the data that's initially collected, the results of processing, the results of analytics, that can all be delivered somewhere. And you can deliver to lots of different targets in a single application. So you can push stuff to enterprise and cloud databases, files, Hadoop, Kafka, etc. As a new breed of middleware that supports streaming integration analytics, it's very important that we integrate with your existing software choices. So we have lots of data collectors and data delivery that work with systems you may already have, whether they're big data systems, enterprise databases, open source pieces. We can integrate with it and do all of this in an enterprise-grade fashion that is inherently clustered, distributed, scalable, reliable, and secure. As a general purpose piece of middleware, we support lots of different types of use cases, from real-time data integration, analytics, and being able to build dashboards and monitor things. And these use cases cross all different industries, and they can range from building your data lake and preparing the data before you land it, doing cloud migrations, doing IoT edge processing, and then on the analytics and pattern side, there's things like fraud detection, predictive maintenance, anti-money laundering. These are some of the things that we've seen from customers around that. And then if you want to build these dashboards and monitor things in real time and look to see whether things are, for example, meeting SLAs or meeting your expectations, then we've done things like call center quality monitoring, SLA monitoring, looking at a network from a customer perspective, and being able to alert when things aren't running normally. And our use cases cross many different industries. There's a lot of text on here. The takeaway is that we have use cases in a lot of different industries. One of the examples is using Striim for hybrid cloud integration, and that's really where you have a database on-premise and you want to move it or copy it to the cloud. And it's one thing to just take the database and put it in the cloud, but that will miss anything that's happening while you're doing it, or miss things that have happened since you've done it. So it's really important you include change data capture in this to continually feed your hybrid cloud database with new information. And so by using a set of wizards, you can build this really quickly. That allows you to join on-premise, for example, Oracle database, and deliver real-time data from that into for example, Azure SQL DB. So you now have an exact copy that is always up to date of the on-premise database. Another totally different example is using us for security monitoring, which is where you have lots of different logs being produced by VPNs, firewalls, network routers, individual machines, potentially microcontrollers, anything that can produce a log. And you recognize that unusual behavior is most often seen by affecting multiple systems. Now, security analysts, they get a lot of alerts from all these logs and all these systems all the time, but a lot of those are false positives. So the goal of this was to identify things that were really high priority for them to look at first by seeing, was there activity happening that was affecting multiple things? So for example, if you have a port scan from a network router that's saying this guy's looking at other stuff, is there any activity on the other machines that it's looked at? Are they doing port scans? Are they connecting to external sites and downloading malware? So by doing this correlation in memory in real time, you can spot threats that are higher priority. And also by pre-correlating all the data together and providing that to the analysts, they can see immediately the information they need rather than having to go and manually look for this across a whole bunch of different logs. And this really increases the analyst productivity. So a couple of other examples from our customers. One is a very simple real-time data movement where data from HP Nonstop and SQL Server databases is being pushed out into multiple targets, whether it's Hadoop HDFS, Kafka, HBase, and they're using Hadoop as analytics hub for their community. So basically ensuring that wherever they want to put the data, that's always up to date and is always containing real-time information from their legacy and other databases. And then the glucose monitoring company are using us to see events coming in from devices, and these are implantable devices, real-time monitoring of glucose. And it's really important that these things work. So they're looking at whether the device is having any errors, whether it's suddenly going offline, and being able to see in real time, are any of these devices not working properly? And this is really important to their patients, because their patients rely on these devices to check their glucose levels. So this has really reduced the time to detect that there's an issue going on and has improved patient safety massively. We are recognized generally by a lot of the analysts in both the in-memory computing and the streaming analytic landscapes. And we're also getting a lot of industry recognition from various publications and trade show organizers, and then also, very importantly, one of the best places to work, which is really vindication of us being a really great company. Our key differentiation is that we're an end-to-end platform that does everything from collection, processing, analytics, delivery, visualization, and streaming data that is easy to use with this SQL language for building out processing and analytics that allows you to build and deploy applications in days. And we're enterprise grade, which means that we are inherently scalable in a distributed architecture, reliable and secure, and that you can integrate us, we're easy to integrate with existing technology choices. So those are the kind of key things to remember about why we're different. So with that, we're going to go into a demonstration. So the first part of this, basically going to show you how to do kind of integration rather than having to type a lot of things. We're just going to go through how to build change data capture into Kafka, and do some processing on that, and then do some delivery into other things. This is pure integration play. We start off by doing change data capture from SQL, in this case MySQL, and build an initial application, and then configure how you get data from the source. So we configure the information to connect into MySQL. When you do this, we'll check and make sure everything is going to work, that you already have change data capture configured properly, and if it wasn't, we'll tell you how to fix it and how to do it. You then select the tables that you're interested in, and we're going to collect the change data from, and this is going to create a data stream. That data stream we're then going to deliver into Kafka, so we're going to configure how we want to write into Kafka, and that's basically setting up what the broker configuration is, what the topic is, and how we want to format the data. In this case, we're going to write it out as JSON. When we save this, this is going to create a data flow. And the data flow is very simple in this case. It's two components. We're going from a MySQL CDC source into Kafka writer. We can test this by deploying the application. And it's a two-stage process. You deploy it first, which will put all the components out over the cluster, and then you run it. And now we can see the data that's flowing in between. So if I click on this eye, you can actually see the real-time data. And you see there's a data and there's a before. That's basically for updates, you get the before image as well, so you can see what's actually changed. So this is real-time data flowing through a MySQL application. But it doesn't usually end there. The raw data may not be that useful. And one of the pieces of data in here is a product ID. And that product ID doesn't contain enough information. So what we're going to do first is we're going to extract the various fields from this, and those various fields include the location ID, product ID, how much stock there is, etc. This is an inventory monitoring table, and we've just turned that from kind of a raw array format into a set of named fields that will make it easier to work with later on. You can see the structure is very different now, what we're actually seeing in that data stream. If we then want to add additional context to this, what we'll be able to do is join that data with something else. So first of all, we'll just configure this so that instead of writing the raw data out to Kafka, we'll write that process data out, and you can see all we have to do is change the input stream. So that will change the data flow now to write that process data out into Kafka. But now we're going to add a cache, and this is a distributed in-memory data grid that's going to contain additional information that we want to join with our raw data. And so this is product information. So for every product ID, there's a description and price and some other stuff. So first of all, we'll just create a data type that corresponds to our database table and configure what the key is. And the key in this case is the product ID. Then we specify how we're going to get the data, and it could be from files, it could be from HDFS. We're going to use a database reader to load it from a MySQL table. So we specify all the connections and the query we're going to use, and we now have a cache of product information. To use this, we modify our SQL to just join in the cache. So anyone that's ever written any SQL before knows what a join looks like. We're just joining on the product ID. So now, instead of just the raw data, we now have these additional fields that we're pulling in real time from the product information. So if we start this and look at the data again, you will actually be able to see the additional fields like description and brand and category and price that came from that other table. And that's all joined in memory. There's no database lookups going on. It's actually really, really fast. So that's writing to Kafka. If you already have data on Kafka or another message bus or anywhere else for that matter, even in files, you may want to kind of read it and push it out to some other targets. So what we're going to do now is we're going to take that data that we just wrote to Kafka. We're going to use a Kafka reader in this case. So we'll just search for that and drag in the Kafka source. And then we configure that with the properties to connect to the broker that we just used. So and because we know it's JSON data, we're going to use a JSON parser. That's going to break it up into a JSON object structure and then create this data stream. When we deploy this and start this application, it'll start reading from that Kafka topic. And we can look at that data and we can see this is the data that we were writing out previously with all the information in it, and it's a JSON format. You can see the JSON structure there. For the other targets that we're going to write to, the JSON structure may not work. So what we're going to do now is we're going to add in a query that's going to pull the various fields out of that JSON structure and create a well-defined data stream that has various individual fields in it. So we'll write a query to do that. that's directly accessing the JSON data, and save that. And now, instead of that original data stream that we had with the JSON in it, when we deploy this and start it up and look at the data, and this is incidentally how you build applications, looking at the data all the time as you're building and adding additional components into it. If we look at the data stream now, then you'd be able to see that we have those individual fields, which is what we had before on the other side of Kafka. But don't forget that it may not be stream writing to Kafka, it could be anything else. And if you were doing something like we just did with CDC into Kafka, then Kafka into additional targets, you don't have to have Kafka in between. You can just like take the CDC and push it out to the targets directly. So what we're going to do now is we're going to add a simple target, which is going to write to a file. And we do this by choosing the file adapter, the file writer, and specifying the format we want. So we're going to write this out in the CSV format. We actually call it DSV because it's delimiter separated, and the delimiter could be anything, it doesn't have to be a comma. And save that, and now we have something that's going to write out to the file. So if we deploy this and start this up, then we'll be creating a file with real-time data. And after a while, it's got some data in it, and then we can use something like Microsoft Excel to actually view the data and check that it's kind of what we wanted. So let's take a look in Excel. And here you can see the data that we initially collected from MySQL being written to Kafka, being collected from Kafka, and then being written back out into this CSV file. But you don't just have one target in a single data flow. You can add multiple targets if you want. We're going to add in writing into Hadoop and into Azure Blob Storage. So what we do is, in the case of Hadoop, we don't want all the data to go to Hadoop. So we'll add in a simple CQ to restrict the data and do this by location ID. So only location 10 is going to be written to Hadoop. That's so some filtering going on there. And now we will add in the Hadoop target. So we're going to write to HDFS as a target, drag that into the data flow, and see there's many ways of working with the platform. We also have a scripting language, by the way, that enables you to do all of this from VI or Emacs or whatever your favorite text editor is. And we're going to write to HDFS in Avro format. So we'll specify the schema file, and then when this is started up, we'll be writing into HDFS as well as to this local file system. And similarly, if we want to write into Azure Blob Storage, we can take the adapter for that and just search for that and drag that in from the targets. And we're going to do that on the original source data, not that query. So we'll drag it into that original data stream. And now we just configure this with information from Azure. So you need to find out, what is the server URL, and you should know what your key is and the username and password and things like that. You're going to collect that information if you don't have it already, and then add that into the target definition for Azure Blob Storage, and we'll write that out in JSON format. So that's kind of very quickly how you can do data integration, real-time streaming data integration with our platform. And all of that data was streaming. It was being created by doing changes to MySQL. We'll now see some analytics. So I have a couple of applications I'll show you very quickly. The applications are defined through data flows. Data flows typically start at a data source. They're doing a whole bunch of processing, and you can have them in subflows as well. And each one of these subflows can be doing reasonably complex things with nested data flows. So if I deploy this application and then we go and take a look at a dashboard, you'll be able to see how you can start visualizing some of this data. So this data is coming from ATM machines and other cash point ways of getting cash. And the goal of the application is to try and spot if the decline rate for credit card transactions, etc., is going up. So what it's doing is it's taking the raw transactions and then it's slicing and dicing it by a whole bunch of different dimensions. And it's trying to spot, has the decline rate increased by more than 10% in the last 5 minutes? And it's doing that across, generally and kind of across all of the different dimensions as well. And each one of these visualizations, nothing's hard-coded in here. It was all built using our dashboard editor, where you can drag and drop the visualizations into the dashboard. Each visualization is configured with a query that tells you how to get the data from the back end, and then a set of properties that tell you how to get the data from the query into the visualization, and obviously other configuration information. So that's kind of an example of one analytics application built using our platform. And we'll just go and take a look at a totally different one that does something completely different. I'll just stop this one. And this one is tracking passengers and employees at an airport. And so the data is coming from location monitoring devices that basically tracked Wi-Fi. And if we take a look at the dashboard for this, you can see it's still a rich dashboard that have lots of information on it, and the data here is coming from location information joined with zones that have been set up. So these zones represent different airline ticketing, and what we're doing is we're tracking the number of employees that are in different places. And if the number of passengers goes up too much and you need additional employees, then it's going to flag it by turning red, and it will send out a request for more employees. And the red dots here are the employees, the white dots are the passengers. So as more red dots arrive in this location, then it will basically notice that new employees arrived at Jira, and the alert will go away because things are actually okay now. And the other thing that is tracking is individual locations of all of the passengers. And this passenger over here just walked into a prohibited zone. So what that'll send out an alert, and now an employee will try and track that guy down and remove him from the prohibited zone. So that's a totally different analytics application, but again, this one was also built using our dashboard builder. So I hope that kind of gives you an idea of the kind of variety of different things that you can do using the Striim platform. And just to finalize things, the Striim can be easily fitted into your existing data architecture. You can start to take some of the load away from what were maybe existing ETL jobs and try and move those into real time. And we can integrate with all of the sources that you may be using for existing ETL, but we can also integrate with a lot of other sources as well, and pull data out of things you may not have been able to access before. But we can also integrate with things you have already. Maybe you have an operational data store, enterprise data warehouse. Maybe you're already writing data into Hadoop. We can integrate with that data, maybe use that for context information. But we can also write that out, so you can use us to populate your operational data store or enterprise data warehouse or Hadoop. And we can also integrate with your machine learning choices as well. So these real-time applications play a really important part. They're a new class of application that give you real-time insights into things, but we can also be part of driving your big data applications and legacy applications. As I mentioned before, the platform consists of real-time data collection across very many different types of data sources, and then real-time data delivery into lots of different targets. The example you saw originally, CDC into Kafka, was just this, very simple, no processing, right? We then added in processing, and that's all done through these in-memory continuous queries that are written through a SQL-like language that can incorporate time series analysis through windowing. And that allows you to do things like the transformation of data that you saw, filtering, enrichment of data by loading large amounts of data into memory through as an external context, and also aggregation of data in order to kind of get what happened in the last minute, etc., or aggregating by dimensions, as you saw in the transactional log analytics. Now, the other piece is the analytics, where we can do anomaly detection, pattern matching through complex event processing, and very importantly, the correlation that is so important to the security application. And on top of this, you can trigger alerts, external workflows. You can run ad hoc queries against the platform if you want to see what's going on right now in a data stream, and also build these real-time dashboards. And we can integrate with your choices for machine learning and do real-time scoring very close to where the data is generated. We integrate with most of your existing enterprise software choices, being able to connect to a whole bunch of different sources and a whole bunch of different formats, deliver to a whole bunch of different targets, but then also integrate with your choices of big data platforms, whether it's MapR, Hortonworks, or Cloudera, your choice of cloud, whether it's Amazon, Microsoft, or Google, and then run on operating systems and virtual machines so that we can run on-premise, at the edge, and in the cloud. Also very well fitted for IoT. We have a separate cut-down edge server that's designed to run on gateway hardware that may not be as powerful as what you'll be running for a Striim cluster. Processing analytics can happen at the edge. We can deliver that data directly into the cloud or into a Striim server on-premise. And you can have these applications that span on-premise edge processing, on-premise analytics through the Striim server, and also cloud. And typically, the amount of data and the speed of the data is greater on the left-hand side, and you're reducing that data down to important information, but it's covering a lot more territory. So you may have, a single edge server is like a single machine in a factory, but then you can have a Striim server that covers the factory, and then the cloud that covers all the factories that an organization might own. And we believe that IoT is not a siloed technology. It shouldn't be thought of separately, especially IoT data. IoT data needs to be integrated with your existing enterprise data and is part of your enterprise data assets. So as part of your data modernization, as you're thinking about IoT, don't think about it separately. Think about, how do I integrate this IoT data and get most value out of it? Because it would be much more valuable if it has more meaning. And it can have more meaning by correlating it and joining it with your other enterprise data. We are one consistent, easy-to-use platform. Not only do we have a converged in-memory architecture that combines the in-memory caches and the high-speed messaging and in-memory processing, but we also have a single UI that allows you to design, analyze, deploy, visualize, and monitor your streaming applications. The key takeaways from this, I hope, is that you really need to start thinking about a streaming-first architecture right now. You need to start thinking about, how do I get continuous data collection from my important data sources, and consider that from a point of view of, what do I require immediate insight into? How do I increase the competitiveness of my company or operational efficiency, or whatever reason you may have for doing it, whatever pushes you might have for real-time applications? How do I go about doing this on a piece-by-piece basis, and start by streaming those important data sources? Also consider sources where your data volumes are going to be growing, and you may need to do pre-processing in flight before you store any data. And that's another area where streaming first is absolutely essential. We believe that Striim is the right solution for this, because we have a streaming architecture that addresses both these concerns and other concerns you may have as well, especially kind of being enterprise grade, being able to run mission critical applications. And you shouldn't be kind of ripping and replacing everything in one go. This has to be kind of use case driven, and it's probably everyone out there has a use case that they need to get some real-time insights into something, and that's a really good place to start. So if you want to find out more about Striim, you can go to the striim.com website. You can contact us over email or the support thing on there. You can tweet us, check our Facebook page and LinkedIn pages as well. And with that, I will open it up for any questions.
Thanks so much, Steve. I'd like to remind everyone to submit your questions via the Q&A panel on the right-hand side of your screen. While we're waiting, I'll mention that we will be sending out a follow-up email with a link to this recording within the next few days. Now let's turn to our questions. Our first question is, what's the difference between streaming first and an event-driven architecture?
That's a great question. Event-driven architecture has been talked about for a long time. I know they were kind of a Gartner category all the way back in like 2002, 2003. The emphasis there was on the data movement. It was on the enterprise data bus that moved things around. And that was where you put your events. And so the whole kind of SOA, event-driven architecture, that bus was the crucial thing. That technology has matured now. We have had message buses around for a long time. We have new ones have come out recently, like Kafka, that have really caught everyone's imagination. But that technology kind of is sound. The important thing we're talking about with streaming first is the data collection piece, that you want to put all or as much of your data as you can into data streams so that you can get to real-time insights if you want to. You could just take those data streams that you've collected in real time and deliver them out somewhere, like to your data warehouse or cloud database or Hadoop, where they just become storage, if that's kind of what you want to do with the data. But as long as you're collecting the data in real time, you're not going to get real-time insights after you put it in a database or in Hadoop. You're always going to have some latency involved by reading stuff from storage. But as you start to identify applications where you do need real-time insights, you can move them into acting in memory straight on the data streams. So what we really mean by streaming first is you are employing enterprise-driven architecture, but you're focusing on ensuring that you at least do the data collection first.
That's great. Thanks so much, Steve. The second question is, how do you work with machine learning?
So there are a couple of different ways in which we've worked with machine learning, and I can do this kind of by way of example. We actually have a customer who has integrated machine learning as kind of part of the overall data flow and use of Striim. And the first piece is essential is being able to prepare data and continuously feed some storage that you're going to do machine learning on. So machine learning requires data, and it requires a lot of data, but it also needs that data to be refreshed so that if you need to rebuild the model, if you start to identify the model's no longer working, then you need to be able to have up to the minute data. And so with Striim, you can collect the data, you can maybe join it, correlate it, enrich it, you can pivot it so that you can end up with a multivariable structure that is suitable for training machine learning before you write that out to your files, Hadoop, database. And then kind of outside of Striim, you can use your machine learning software, and this customer, the data they were collecting was web activity and VPN activity and other stuff around users. And they pushed all of this out into file store and then used H2O, their choice of machine learning software, to build a model. And the model was modeling user behavior. What do users normally do? What is the usual pattern of activity for each one of our users? When do they logging in? When they're accessing things? What applications are they using? What order of applications do they have? And they built this machine learning model that expressed all of that. They then exported that model as a jar file and incorporated it into a data flow straight from the raw data in our platform. So the raw data was going through the processing into the store, but then we're also taking that raw data in memory in a streaming fashion and pushing it through the model and checking to see whether it matched the model, and then alerting on any anomalous behavior. So the two places where we really work with machine learning are delivering data into storage so machine learning can learn, and then once it's learned, taking the model and doing real-time inference or scoring in order to detect anomalies, make predictions, etc.
That's a great example. Thanks. I think we have time for just one more question. This one is, Confluent just announced SQL on Kafka. How does that compare to what you do?
Well, SQL on data streams is a great idea, and obviously we've been doing that for almost since the inception of the company. Anyway, it's brand new, right? So it's not going to be mature for a while, but it's only looking at a small part of everything that you need in order to actually do all the things that I showed you today. Being able to run SQL against a stream and against a window is one thing, but there are other types of things we need to incorporate. For example, we can incorporate data in a distributed data grid, so cache information, data in result storage, and feedback results into processing, and a whole bunch of other things. But I think the primary thing that I see is that they're focusing on interactive ad hoc queries against streams, and that's good, being able to just see what's going on in the stream and analyze it. But the power of our platform is combining your sources, queries, targets, caches, results, everything into a data flow that becomes an application that you can deploy as a whole. And so it's going to take a while until all of the things that we've spent the last 5 years working out, like a good role-based security model for these types of queries, how do you integrate them into a whole application, how do you deploy that application across a cluster, all of those kind of things that are essential for mission-critical applications that we support at our customers that utilize this SQL. So I think being an end-to-end platform, we can do all of that. I think having to combine all the pieces together so this SQL may be useful might be harder with the KSQL that was announced earlier this week.
Great. Thanks so much, Steve. I regret that we're out of time. If we did not get to your specific question, we will follow up with you directly within the next few hours. On behalf of Steve Wilkes and the Striim team, I would like to thank you again for joining us for today's discussion. Have a great rest of your day.